Now for the next step, and this is, I guess, D2, we're going to make use of this chart, or one that you look at on the internet, to figure out what the resistance of this resistor is. And I've got it set up, and hopefully you can see, very light all the way on the left side, there's a yellow band. I think the next band over, it looks to me to be purple. And then finally, the third band is black, and then there's a gold band. And so let's see what the resistance of this resistor should be from that color code. If I come up to here, well, I see yellow is pretty clearly a 4, purple is a 7, and then black says multiply by 1. So that would be yellow, purple, 4, 7, multiplied by 1, 47 ohms. The gold, you'll notice, says that the uncertainty, the manufacturer's tolerance, I think it's saying 5% for a gold band. Okay, so manufacturer expects this resistor to be 47 ohms plus or minus 5%. And I looked at it, of course, with a, stop it. You saw what it was before I started moving around. About 47 ohms is what I'm measuring. 47.3 ohms is what I'm measuring with my multimeter. All right, I've got a helpful camera person here. If you've been watching The Tonight Show, you saw that Jimmy Fallon's wife has been doing the photography for him. My wife is doing the same for me. Thank you very much. What I've got here is a simple series circuit, but I've changed it from the last experiment we did. There's the brown resistor we used before, and I added that one that we just determined from the color codes, 47 ohm resistor. So I got two resistors in series, and I'm going to hook them up to the battery, and the circuit is now running. I don't have any of my sensors in because I want to make sure you understand how you go about putting a sensor into a circuit. These are the current sensors, the ammeters. And in order to put a current sensor in, I actually have to physically break the circuit. And I'm putting this ammeter roughly in the position of A on your diagram. And then I've got to use the ammeter to complete the circuit between the battery and the 47 ohm resistor. So the first current sensor is in place. And if you come on over to here, you can see the current, and that current sensor is measured as current 1. Coming back around, I'm going to put a second current sensor in here in between the two resistors. That would be position B in your circuit diagram. And again, I disconnected the wire there. And the current sensor completes the circuit because the current sensor goes in series with the resistors. So I'm going to connect it from right there to right here. And as soon as I do that, current begins to flow again because I've got a complete circuit. And if you come on over to here, you can see that those two currents are exactly the same, or pretty close to being the same, which is what we said should happen for a series circuit. The two currents should be the same. Okay, the last thing I guess I have to do is you've got a table you've got to complete in, looks like step 5 over there. And so we'll start just like we did before with the battery. And I'll put the two alligator clips without disconnecting them across the battery. And as you recall before, the battery was about 2.4 volts. And of course now it's not going to hold. So I'll just hold them in place here. And if you look, if you can go over there, you can see 2.4 volts is the battery voltage, the potential difference across the battery. Okay, I'm going to try to disconnect those now. You see I disconnect them, it goes to 0. The next thing I want to do is find the potential difference across the ammeter. And if you come over to there, you can see it's pretty small, about minus 0.008 volts. Okay, and then I'm going to come across, always leading, put the red in front, the potential difference across the 47 ohm resistor. And you can see minus 1.45 volts. Okay, now I'm going to take the potential difference across the next ammeter, including the wires, in case you're wondering. And I can come over to here and about negative 0.008 volts again. And then finally the potential difference across the unknown resistor from the previous part, which hopefully you have a value for now. Okay, and you can see it's negative about 0.97 volts. And now I'm back to the battery, so I think we're done. We've got all the pieces on the table, and we can stop.